Thank you all for joining us. I'm Candace Shively with Utah State University Extension, and we also have Satal Priyal joining us, who is also from USU. We are both associated with USU Center for Water Efficient Landscaping, which is the organization that supports these events. This month, we have Dr. Kelly Cope joining us. She is our USU Extension Turfgrass and Water Conservation Specialist, and she's also the director of the Center for Water Efficient Landscaping. Today, she is going to discuss just how resilient turfgrass is. She's going to cover some management practices, including pesticide use, nutrient management, irrigation, among some other things that can help improve the drought tolerance and resilience of the turfgrass areas. So with that, I will turn it over to Kelly.
Thanks, Candace, very much. And welcome, everyone. I'm happy to be with you again. It's always a lot of fun to participate in these webinars. So the title today, How Low Can You Go? It's really sort of a tongue-in-cheek approach to turfgrass management during some pretty challenging weather conditions and climate conditions that we're facing right now. So as Candace said, I'm going to be talking about a lot of different aspects of turfgrass management, but I generally start out by introducing the topic a little bit. And of course, for those of you who certainly those of you who live in the central and southwest southwest states of the US, you're very well aware of our current drought conditions. And as you can see here, just indicated by the darker colors, there is a large portion of the country right now that is experiencing extreme drought. Now, here in Utah, we are definitely one of those locations. We have areas under exceptional drought, extreme drought. Every part of our state is experiencing some aspect of drought with some different severity. And we're also dealing now with a lot of impacts. And these impacts aren't exclusive to Utah, but these are the ones that we are dealing with most. We're dealing with increased fire risk. We are having plant and wildlife impacts, relief, response, and restrictions. So in particular, water use restrictions are occurring here. It's affecting our tourism and recreation industries, and of course, overall water supplies, and in addition, water quality are of concern. So it's certainly top of mind for everyone. I was doing a little checking into it, and the drought that we are currently experiencing is the worst that we have experienced in the past 1,200 years. So definitely an issue, something that we have to address. In terms of plants in drought and turf grasses, that's what I'm primarily focusing on here today in drought. What happens when they are exposed to drought is that every single plant process is affected. Growth is slowed down. There can be increased reflectance of sunlight from the leaves, increased leaf temperature, of course. There can also be some other compounding factors like decreased nutrient uptake, and there can be mineral accumulation in leaves, which can also affect the overall ability of the plants to withstand stress. So there's a whole lot of things going on with plants that are living under drought conditions. So with all of that as an introduction, I wanted to just outline what I'm going to be talking about today and put it in the context of an integrated pest management approach, because we can talk a lot about managing turf grasses under drought conditions, and people often think that the focus there is on irrigation, and it is on irrigation, but it also has to do with our other general management practices. And in particular, what happens when we try to manage pests, whether it's insect pests, disease pests, what have you, weeds, under drought conditions. So I've got this organized in terms of things that can be done before drought, during drought, and after drought. And I'll talk in more detail about all of those different aspects. So, at this point, we're in August. And so we're, at least in Utah, we're already through the hottest part of our summer. So this is maybe more advisory for next summer or for future drought situations. But there's so much that can be done before drought so that when drought does occur, you're in a better position. Namely, one of the first things that can be done is to implement integrated pest management. And I'm not going to get into great detail on integrated pest management, although I will recommend certain practices. But basically, it's using different management strategies and the judicious, I want to emphasize the word judicious there, use of pesticides to prevent, reduce, and potentially eliminate pests. So a lot of things happening in conjunction with one another, identifying pests, monitoring for those pests, and then using different tactics to address them so that they are either eliminated or kept at a level that is not damaging to the plants. So some of these things can be done in different parts of the year. In the springtime, we focus on doing things in turf areas like raking out dead areas, reseeding thin or bare areas, applying certain pest controls, including crabgrass and winter annual weed controls. And then one of the primary ones, at least in our region, is monitoring for white grubs and applying control where it is warranted. Now, I don't have time today to get into all of the details that I would normally share about addressing and managing for white grubs, but we do here in Utah have a lot of extension resources that you can access to find that information. And this is also going to be true in other states. And you can access this type of information often through your land-grant university. But this is just an example here in Utah. So those are spring IPM things that we focus on. And then as the season goes on, you can continue monitoring for certain pests. So white grubs, yes, but then we start layering in some other pest monitoring. In our case, for example, we often get bluegrass billbug occurring in later spring. And so that would be our next focus in terms of spring integrated pest management. And again, we do have resources to support folks in our state and region actually for their management. And that is likely the same for you too in your locations. I don't think I mentioned it, but I do want to make sure to mention that this presentation is a summary form of a much larger presentation that does include a lot of details on this pest management. And so at the end of the presentation today, I'm going to have my email on that last slide. And if you're interested in that more extended presentation, I'm very happy to share that if you reach out to me afterward. All right, so also in terms of late spring integrated pest management, that's a time when we start thinking about certain weeds in our turf grass areas. In particular, crabgrass becomes an issue, and so we start to monitor for that and consider treatment. Now, having said that, one of the most important things I want to share today are the considerations that should be made when you're using herbicides during drought conditions. During drought conditions, what we find is that herbicides are much less effective on those weeds. And in addition, they may actually damage stressed turf grass. And so that's something that you really have to keep in mind when deciding whether or not to treat with herbicides on drought stressed turf. So there is a rule of thumb that I often share with folks, and that is that if the turf is 50% green or more, then it's likely okay to apply those herbicides. But if it is less, then you should really wait. And you might consider hand pulling or spot mowing those areas. And you certainly don't want to be using herbicides at high temperatures. And I'm going to describe the reasons for that as I go. But there's some other things to consider as well. During drought conditions, when it is very hot, there is a higher chance of drift when spraying herbicides. And of course, that is something we always want to avoid because we are targeting certain species, not others. And so we don't want to be applying herbicides or pesticides of any sort under conditions where they may drift easily. They're also more subject to volatilization, so essentially evaporating and becoming into the atmosphere and not doing what they're supposed to be doing. And many herbicides and pesticides depend on moisture to be taken up, whether it's by a plant or an insect or a fungus. And so if there is a lack of moisture, as you would have during a drought, that can mean that they don't break down as they should, that they might persist longer in the soil or on the plants than they would normally. So that's something to consider. In addition, the time of the application should be considered, but not only the actual time of application, but what's going to be happening in the 48 hours after the application. Because if it's going to become extremely hot or extremely dry during those 48 hours, then you have to consider that as well. Some other recommendations would be choosing products that are less likely to drift or volatilize. not spraying, particularly where there might be sensitive areas nearby. And then some practical things that you can do. There are nozzles out there that can reduce drift when you're applying pesticides. There are nozzles that apply them in larger droplets, so they're more likely to stay in place as opposed to drifting. There are spray adjuvants that can be included in mixtures with herbicides and pesticides to keep them in place. And of course, and I think this is common sense, but I think bears repeating always, and that is avoiding peak heat and wind when you're applying these products. Those are all things that have to be considered. And I think the last thing I want to add here is that when you're using a product, a pesticide product, an herbicide product, a fungicide product, what have you, oftentimes on the label, there will be guidance in terms of temperature and what temperature you should stop applying pesticides. So I'm thinking on the high end. So for example, certain herbicides you're not meant to apply above 85 degrees Fahrenheit, and they all have that kind of guidance that should be considered. Okay, so moving on to summer now. Essentially in the summertime, we are still monitoring in an integrated pest management approach. We are still monitoring for all sorts of pests. In our case, we are dealing more and more with chinch bugs. We are dealing quite a bit with sod webworm, as well as occasionally Japanese beetle, which is a ubiquitous pest all over the US. And so as we enter the summer months, we have to be looking for those pests. And we do have, again, some supporting materials through USU Extension for these insect pests that are very commonly seen in our turf grass areas. And those should be available to you wherever you may be as well. So in the fall, we have to start thinking about different things. We may have seen increased pest activity during the summer because of drought. We may have seen some significant damage to turf areas because of drought, but in the fall, things tend to start cooling off. We can start to get improved moisture conditions, and we can start to think about renovating or reseeding turf grass areas. It's a perfect time to do so, particularly with our cool season grasses, and we begin planning for that in the fall. Now, related to that, I want to talk about a couple of different programs that we are participating in. We here at USU and in the Center for Water Efficient Landscape do extensive turfgrass species and variety trialing. And that is because we know that even under drought conditions, if turfgrass is used in a functional / recreational manner, that can be appropriate as long as it's managed appropriately. It can still be managed with great water use efficiency. But to achieve that, we have to be able to utilize species and varieties that perform well under drought conditions, species and varieties that are going to use the least amount of water while still accomplishing the function that they are meant to accomplish. And so we participate, as I said, in many, many different programs for trialing different species and varieties. These are some of the organizations that we participate with, in particular, the Turfgrass Water Conservation Alliance and the Alliance for Low Input Sustainable Turf. They're very focused on low water use grasses and developing low water use grasses. The National Turfgrass Evaluation Program and the United States Golf Association are also starting to do more and more of that type of work as well. And without getting into too much detail about all of those various programs, I did just want to touch on the types of testing we do when we work with those different organizations. So we might test chronic drought stress, where we're still irrigating on a regular basis, but it is at a decreased level. So perhaps 50% of what we might normally do. We also conduct trials where we're implementing acute drought stress, meaning we simply stop irrigating and we don't irrigate again until the absolute best performing grass reaches 25% green cover. Everything else might be completely dormant, but we wait until the very best performing grass reaches that 25% green cover. And so these two approaches allow us to identify species and varieties that work well. And so related, I wanted to give a practical example of how that information might be used. We cooperate with Salt Lake City Department of Public Utilities on a project called the Turf Trade Project. And this is a public-private partnership that we have been participating in with the city as well as the Turfgrass Water Conservation Alliance. We developed a customized seed blend for the city that they provide at cost to their residents. And that mixture is comprised of proven low water use varieties of grass. And so the annual irrigation requirement is vastly reduced. This past year, this is some of the promotional materials for the program. This past year, we actually converted one of the city's, this is actually a municipal water pump station in the city, but we converted an existing turf area to these low water use species and varieties. And so we went through that process. You can see an aerial view here. And we went through the process by mowing the existing turf very, very short. We used a non-selective herbicide to spray it out. And then we overseeded with the new improved varieties in September of 2021. And frankly, I have to tell you, I was a little concerned with that timing because we're never exactly sure when we're going to get our first frost, but we were hoping to have at least 6 weeks for the new seed to germinate before that first frost. So seeding at the end of September was a bit risky as far as I was concerned. Once we did do that seeding, we top dressed with compost just to keep some moisture in the seed bed. And what we found was within the following 6 weeks, we had really great establishment. Everything was looking terrific, and it still is. And so that program is going on in Salt Lake City now, and it is as a result of some of the trialing that we've done with USU. All right, so moving a bit away from IPM at this point, I want to talk about other things that can be done before drought conditions occur. Optimizing and testing irrigation systems is one of the primary things that can be done. And a number of different things can be taken care of when regular maintenance occurs. So sprinklers that are malfunctioning can be replaced or fixed. Sprinklers can be adjusted so that they're spraying where they are supposed to be spraying. Other things can be taken care of, like matching precipitation rates, matching nozzles, even matching brands if that is not the case currently. And then poorly designed irrigation systems may be adjusted if that is practical. And so that can help with optimizing the irrigation system as you go into the irrigation season so that the best, most efficient use can be made of the water that's available. And I want to qualify all of this by saying this would still be within the constraints of whatever irrigation restrictions or guidelines might be in place where you are. Another program that we have here in Utah and that is also available in much of the Western US is the Qualified Water Efficient Landscaper Program. And I mentioned this in relation to optimizing irrigation systems because it is a program that really focuses on managing landscapes and irrigation systems efficiently. It covers irrigation auditing, system maintenance, and troubleshooting. And so I would just encourage you, if you are in the Western United States, and in particular, if you are a landscape contractor of some sort, to check this out. It's a fantastic certification to have. And it is actually an EPA WaterSense certification as well. Some of the other things related to irrigation system optimization to consider, there are a number of really effective irrigation technologies out there these days. And over the years, we have participated in a lot of trialing and testing of those products, including different types of irrigation controllers, including weather-based irrigation controllers, as well as Wi-Fi enabled irrigation controllers. And in both cases, what we have done is test these controllers on what a traditional landscape might look like. So it would include a turf area as well as ornamental plantings. It might include overhead irrigation as well as drip irrigation, but that is the type of system that we test these controllers on. In the case of the climate-based controllers, we've tested a Rainbird ESP-LX modular series with an ET Manager cartridge. We've tested the Hunter Solar Sync. We've also tested a Weathermatic series controller. And then we also include as a control, a standard manually programmed Hunter XC400. For the Wi-Fi enabled controllers, we've tested Orbit's Beehive controller, Rachio's Smart Sprinkler controller, and we also tested the SkyDrop Halo Smart controller with the same Hunter as for comparison against all of those. And to sum it all up, I just will share that with the weather-based controllers, we found significant savings ranging from 37 to 48%, depending on the controller. And with the Wi-Fi enabled controllers, also significant savings ranging from 29 to 55%, depending on the type of controller. So these are very effective. They do require pretty significant programming depending on the controller. And that, I think, is an area of work that I'm considering looking into in the future, how we help folks take best advantage of this technology. So we're looking at that. All right, so moving on, choosing drought-resistant plants and varieties. I did already mention some of the drought-resistant turfgrass plants and varieties, but there are also other landscape plants out there, of course, and we want to choose those as well, choose them for their water use efficiency. So actually, I might invite my colleague Sital at the end to chime in on this, but we do also in the Center for Water Efficient Landscaping participate in ornamental plant trialing. So we do a lot of turfgrass trialing and we do a lot of ornamental plant trialing, and that is expanding as well. And I would encourage you, particularly if you are in our area, to visit some of the demonstration gardens in areas that are out there. So the USU Botanical Center, for example, the Conservation Garden Park at Jordan Valley Water Conservancy District. There are others, the Greater Avenues Water Conservation Demonstration Garden in Salt Lake City, Red Butte Gardens in Salt Lake City, the Red Hills Desert Garden, which is in St. George, several others as well. And USU Extension is also a good resource for this type of information. But of course, we are not the only extension service in the country. Those exist in every state, and I'd encourage you to contact yours to help choosing some of these plants. So lastly, before drought, we can recommend testing soil and using water-wise planting practices. This is a real key to drought avoidance in landscapes, whether it's turf grass we're talking about or ornamental plants, regardless. An adequate soil condition is going to improve the plant's abilities to handle drought conditions. And so inspecting soils, making sure there is an adequate depth of topsoil, that's probably the #1 problem that I see, at least in this region. Improving them if at all possible. So in our case, that can include things like adding organic materials, because we tend to have low organic matter content soils, improving the depth, etc. In terms of water-wise planting practices, there are some basics here. And again, I do have a lot more information in the full presentation, but planning is of course key, I think, to everything in life, not just landscape management. But planning is of course going to be very, very helpful. Using practical or functional turfgrass areas. I recently heard turfgrass areas referred to as recreational rather, and I thought that was a good way to think about it as well. If the turfgrass is being used for some purpose, and it's often recreation, then that is an appropriate use of that plant material. Improving soils, we discussed selecting appropriate plants. Mulching, that's one of the top things that can be done in terms of retaining soil moisture. Mulching bare soils can help maintain soil moisture on site. Irrigating efficiently, which can be helped with climate-based controllers, Wi-Fi enabled controllers, or a good healthy understanding of plant water requirements. And then one of the things I think is sometimes overlooked, at least, is maintenance. And maintaining the plants, pruning as appropriate, removing some that aren't working, moving things around and changing things. That is also all going to help in terms of being water-wise with our landscapes. Now, there's some other things that can be done more specifically for turf grass in terms of preconditioning the grass for drought conditions. So one of the things is encouraging as much root growth, as much rhizome growth and stolon growth as possible, because all of those things are going to give a grass plant more resilience. One of the things that takes place on our university's campus is a very aggressive aeration and top dressing program. And that's not always practical in every case, But in the case of our university, they have made very good use of those practices and done incredibly well in terms of maintaining the quality of the turf grass areas on our campus, as well as reducing the overall irrigation amount. Reducing compaction, which is done with aeration as well, is incredibly important. And then irrigating to impose mild drought stress before we actually get into the heat of the summer is another way to approach it. And this is a really important one. Not over fertilizing. So we want to be adequate with fertilization because it helps with turf grass resilience and recovery. But we don't want to over fertilize because it actually causes the grass to use more water. So during drought, we want to be monitoring for signs of stress, not over fertilizing, as I say, and not over watering. And in fact, it's counterintuitive. But when grasses do start to enter dormancy, so that straw yellow color that you can see there, that's actually a time when you really want to avoid overwatering because it can actually stress the grass even further. And again, that's very counterintuitive for most folks. They see that color and they want to apply more water because they think it's going to be helpful when in fact it isn't. And if traffic can be limited, that's also helpful. With ornamental plants, you can be looking for leaf dropping and scorching, wilting, yellowing, footprinting in the cases of turf grasses or ground covers. Those can all be signs of drought stress. And then in terms of turf grass management during drought, irrigating in the morning if at all possible, checking the root depth, making sure that that's adequate, and then taking steps to increase that if at all possible. Avoiding over irrigation, as I mentioned, that's something people often want to do during drought, but it can be counterproductive. There can be increased disease incidence. You can actually get something called wet wilt, which is wilting due to over irrigation. And so something that can be done is, in terms of irrigation, is syringing, which really just means applying a very small amount of irrigation. And it's really only meant to cool the temperature at the surface. It's not really meant to put enough water down so that it's penetrating the soil and going way down into the root zone. It's really simply meant to cool the surface and the leaf temperature. And then you can monitor the crowns of the grass plant, which you see there noted. And can you see my arrow, Candace?
Yes, yes.
Thanks, Satal. So right here, this is the crown of the grass plant, and that's something that you can monitor over time just to simply make sure the plants are still alive if it's of concern. Because oftentimes when people see yellow grass, they think it's dead, but really the plant is just protecting the crown, and so you can monitor that over time. Another really good practice is mowing high. It's something that is going to improve the environmental stress tolerance of grasses. It's something that we recommend very, very often. And what it also does is help to suppress weeds. So that's part of an integrated pest management practice. It facilitates deeper rooting, and it actually provides more photosynthetic area. So longer leaves mean more photosynthetic area. After drought, we're not quite there here in Utah yet, but we're getting there. You can assess the damage, aerate, fertilize with care. Still don't overwater at this point. And hopefully you will have been mulching the clippings throughout the growing season. And this might be the time to make a plan for renovation. So I did also just want to share some drought related studies that we have been conducting here at USU. The first of which we implemented last summer, and this was an infrequent irrigation during drought study. And so this is was conducted on an existing stand of bluegrass, and it had been established from sod, but we had 9 plots, and they either received a 1/4 inch, a 1/2 inch, or 1 inch of irrigation water per month during the growing season. And that was applied during one application. So if you can consider a 1/4 inch of irrigation applied once per month through the entire growing season last summer, as well as the other treatments. So that's what we implemented. And you can see here in August, everything was very, very dormant. But in September, as the temperature started to cool, things started to recover. And that recovery kept going. These yellow boxes are around the plots that received 1 inch of irrigation per month. And so in this case, we had just about full recovery. The others maybe not quite so much. But we did have decent recovery at the end of the growing season, but it also got us thinking about what might enhance that recovery and what kind of other research we could do, which I'll get into here in a minute. But I wanted to just also show this depiction of the data that we collected from this study. So this dashed line indicates an acceptable level of green cover in the turf grass. And at the beginning of the season, every one of these treatment plots was fairly close to that acceptable level of cover. It declined a lot during the midsummer, but then at the end of the summer, everything again was getting on average close to that acceptable amount of cover. But again, we were still considering what could we do to improve this process? What could we do to enhance turf grass resilience and recovery? So we also conducted a study in which we looked at different nitrogen rates under very much reduced irrigation levels. So in this study, we had a range of fertilization rates ranging from 1 pound per 1,000 square feet to 6 pounds per 1,000 square feet of nitrogen fertilizer. And then we were only irrigating at 50% of evapotranspiration, and that was being applied twice per week. So that's still a very reduced level of irrigation, but we were considering now what happens with increased fertilization. So here you can see in June, things were quite dormant and you can't tell a lot of difference between the plots, but then things recovered as we went through the summer. By August, we were starting to see really good recovery, particularly with the higher fertilization rates. So the yellow boxes are around the plots that were receiving 6 pounds of nitrogen per 1,000 square feet. And then by September, things were really looking very similar and we had complete recovery of all the plots. So this is similar to what I showed you before with the minimal irrigation study, but this dashed line indicates the level of acceptable green cover, and our plots were all at that level before the study. They were all below that level in the middle of the summer, but they all increased and actually got even better after the study, once things cooled down and there was some adequate moisture. And so what we learned from this is that even at vastly reduced irrigation amounts, fertilization can help these grasses recover quite well after the heat of the summer has passed. So we're going to be continuing these infrequent irrigation studies this year. We're going to continue promoting the use of low water use plants and turf grass varieties. And I'm thinking more about the best fertilizer rates for recovery, particularly after extended dormancy. And then in response to questions that I've been getting from industry folks, from landscape managers, municipal folks, I think we're going to start considering weed incidence and management. That seems to be, at least in our region, the biggest issue that we're facing when we're managing turf grasses under drought conditions. We seem to have increased weed incidence. And so our research questions are starting to formulate around what can we do to address that so that we can maintain the functionality of the turf grass. So we conduct a lot of research, but we do it with the support of many different organizations in the state that you see listed here, several of the water conservancy districts, as well as the Division of Water Resources and our USU Extension Service. And just quickly, I wanted to share these resources with you as well if you'd like to have more information. But with that, I'll wrap it up, and there is my email address, and you're welcome to reach out if you'd like a copy of the more expanded presentation or even this presentation as well. So I'll wrap it up there.